So before we get into this, so now the first part we are going to learn how the addressing is done. So that's what we call as IP addressing. Generally we call it as a IP addressing. Addressing is just like a naming given to each and every device in the network. So when you talk about a LAN or WAN, let's say I got a LAN where I got some multiple computers in my LAN, and I want these computers should communicate with each other, and also they should communicate with router, and from the router again it is connecting to some other router somewhere, and then there is another branch office over there where I got some multiple computers. So I want to make sure that the users connecting on the LAN 1, this is my LAN 1 which is in separate location, and I got a second LAN 2 which is in a different location, and I want this LAN 1 and LAN 2 should communicate whatever. It can be in the same LAN or in multiple LAN. Even if I want these users in my computers should come in the LAN, in the same LAN, should communicate with each other, then every device should have a unique address, and that address we call as IP address. So IP address is the addressing scheme given to each and every device in network. Just like every person is identified with some name, so name generally identifies a person. Similar way, every device in the network is identified with some address. We call that as IP address. Generally we call it as IP address. So that's what we are going to see, what is IP address and how it is defined, how it looks, and how we need to understand it, how the devices will understand. Anyway, devices understand this addressing, so we just need to try to understand how it is defined. That's what we are going to see here. So IP address is a logical address given to each and every device in the network, so which identifies each and every device. And there are two versions of IP addressing. We have IP version 4 and we got something called IP version 6. Okay, so let us move on with the different versions. So first let us try to understand the different versions here. Fine. So IP address, mainly there are two versions of IP addressing. We got IP version 4 and we got IP version 6. IP version 4, which is the standard addressing which is still used, which is a 32-bit address written in generally decimal format. Generally you'll find in decimal format, whereas IP version 6 is 128-bit address written in hexadecimal format. So we'll get into some introduction to IP version 6 as well. You can see this is my IP version 4, how it looks. So let me take down this here. So IP version 4, I got a sample address here. You can see some sample address of IP version 4 here. So IP version is actually 32-bit address. You can see it's 32 bits, binary digits, but this 32 bits is classified into 4 portions. Like you can see, this is my first portion and this is my second portion, the same address I wrote here. This is my third portion and this is my fourth portion, where each and every portion is having 8 bits and each and every portion is separated by a dot. You can see each and every portion have a dot. So in general you got 4 octets, or we can say 4 portions or 4 octets. The first octet, second octet, third octet and fourth octet, or we can say 4 portions. So 32 bits is divided into some 4 octets. So this is the group of 8 bits, but generally it becomes very difficult for us to understand and remember the IP addressing in the form of binary. So for our convenience we are converting this into decimal numbers. So let me just take this example how to convert binary to decimal. So I'll just give some idea. If I take this number here, so the number is 01 01 01 01 01, so it's like 01 01 01. Okay, so this is my number here. So to take 2 power values, so to take 2 power 0 here, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5, 6 and 7. So if I just add these 2 power values, you can see 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 16, 32, 64 and finally it is 128. So wherever there is 1 we need to add those values. Like here if you see here, so this is 1, so I'm going to add 64 plus I'm going to add this 16, which is the equivalent power value. I'm going to add this 4 and I'm going to add this 1. So wherever there is 0, you don't need to add those values. Wherever there is 0, no need to add those values. So now if you just add 64 plus 16, it becomes 80, 84, 85. So the equivalent decimal value for this is 85. Similar way, the same calculation here. 85 dot 5 dot, you can see it's 191.1. So in general, the IP address looks like this, but the computer understands only in the form of binary. So this example will give some simple idea on how exactly IP version 4 address looks. Okay, so now IPv6, you can see here, this is one sample address of IPv6. It's actually 128-bit address, which is written in 8 portions. Each and every portion is having 16 bits. Like that, we have 8 portions: 1, 2, 3, 4, 5, 6, 7, and finally 8. So we got 8 portions in total. It's 8 into 16. It's 128-bit address. So we'll see more in detail about IP version 6 later on sessions. So our main focus in this class is to make sure that we understand the IP version 4 addressing. Okay, so we confirm that from these examples we can confirm that okay, each portion is not going to have more than 8 bits. So each portion will have only 8 bits. So that is something we can confirm from this scenario here. So fine. So now from this scenario we make sure that there are 8 bits in one portion. If you count, minimum number is 8 zeros. You can see here 8 zeros is the minimum number and the maximum number is 8 ones. So which means if you count this, so the range of IP address start from 0 to 255. So this is the range of IP address. So IP address range is just from 0 to 255. Anything more than 255 is not present in any IP address. So if you want, you can probably try assigning the IP address on your network computers. Like you can go to network places, you can go to my adapter settings and you can just check out. So anyway, I'm not using this LAN card, so I'll go to this properties. So TCP IP properties, if I just try to type 100 dot, if I just try to type 256, you can see the message here. It says 256 is not a valid entry. Please use the values only in between 0 to 255. That is what exactly IP address range. So in general, the range of IP address is only between 0 to 255. So that's what this example says, that a range is from 0, starting from all zeros and ends on all 255s. So this is the range of IP address in general. And again, this range is further classified into 5 classes. And they said that 0 to 127 is A class, 128 to 191 is B class, 192 to 223. So let me write down it very clearly here. So now they said, so A class, B class, C, D and E classes. And they said that 0 to 127 is A class, 128 to 191 is B class, and 192 to 223 is C class, 224 to 239 is D class, and 240 to 255. So the first thing in IP addressing is whenever you see any address, you should be in a position to identify the class. Like if I take an example, I'm going to write 192.168.10.10. So this is my IP address. So now if I ask you which class this IP address belongs, means simply we need to see the first portion, because the classes are divided based on the first portion. 192 comes in between the range of C class, so it is a C class address. Similarly, if I take an example, so you should not never see this. So remaining 3 portions can be anything in between 0 to 255. The remaining 3 portions. But if the first portion is in between 0 to 127, you have to understand it's a class. If it is in between 128 to 191, you have to understand it's a B class. And anything in between 192 to 223, we need to understand it's a C class address. Anything in between 224 to 239, it's a D class. anything in between 240 to 255, it's a class E address. So only you have to see the first portion, because the classification is divided based on the first portion. So let's take some 2 more examples to have a more better understanding on this IP addressing. Like if I write some address 150.12.10.10. So if I just say this address, so now if I ask you which class this IP address belongs, so we just need to see only the first portion. And 150 comes in between the range of 128 to 191, which is a B class address. So don't say this, okay? So this can be anything. So don't think that it is A class, because this is range, so it's not correct. So this can be anything in between 0 to 255. So similar way, one more example. If I say 100.10.10.10, so if I just ask you which class this IP address belongs, so 100 comes in between the range of 0 to 127, so it's a A class address. So these numbers can be anything in between 0 to 255.